So the S block elements of the periodic table we can define as the last or outermost electron enters into the s orbital. So those are called as the s block elements. The last or outermost, and it is also called as valence electron. So outermost or last electron is also called as a valence electron. The last or outermost electron enters into the s orbital. These are called as the s block elements. The last or outermost electron enters into the s orbital are called as the s block elements. And we have the s orbital, it has capacity to accommodate only 2 electrons. Maximum it will accommodate 2 electrons in its orbital. So that is why we have to fill either 1 electron in the half fade system, or we have to fill 2 electrons to become a completely fade one. So since the s block elements are involving 2 groups, one is group 1 elements, and these are called as alkali metals. The group 1 elements are said to be alkali metals because whenever they are react with the water, they form hydroxide. Those are alkali in nature. So that is why these are said to be alkali metals. The group 1 elements, when they are reacted with the water, they form their hydroxide. They will form their hydroxides. So these hydroxides are alkali in nature, means basic in nature. So that is why hydroxides are alkali in nature. Since we can call them as alkali metals. The group 1 elements, when they are reacted with water, they will form their hydroxides. Those are basic in nature or alkali in nature, since the group 1 elements are said to be alkali metals. Then what are the group 1 elements? So those are lithium, sodium, potassium, rubidium, cesium and francium. So these are the group 1 elements, and here the lithium is the more electropositive in nature, and if we consider the abundance, the sodium and potassiums are more abundant in the nature. The sodium and potassium, these are more abundant, but the lithium, rubidium and cesium, so these are less abundant or else a rarer one. Cesium are less abundant, and the francium is said to be radioactive one. So the francium has radioactivity nature, so then it is said to be the radioactive element. So that's why the group 1 elements are said to be alkali metals. So the group 1 metals are said to be alkali metals, and these include lithium, sodium, potassium, rubidium, cesium and francium. So next is the group 2 elements. So S block have two groups. So in first group is said to be alkali metals, and group 2 elements are called as alkaline earth metals. The group 2 elements are called as alkaline earth metals. So these are called alkaline earth metals. So these group elements include the beryllium, magnesium, calcium, strontium, barium and the radium. So these are the group 2 elements. So these are said to be alkaline earth metals because whenever they are react with water, those are also form oxides as well as the hydroxide. So those are in alkaline nature and they will found in the earth crust. So that is why the name of the group 2 elements is the alkaline earth metals. The oxides and hydroxides of group 2 elements are alkaline in nature and those will found in the earth crust, since these are called as the alkaline earth metals because the hydroxides and oxides of group 2 elements are alkaline in nature and found in earth crust. So that is why the group 2 elements are called as alkaline earth metals. So these group 2 elements include beryllium, magnesium, calcium, strontium, barium and radon. Radium. So these are the group 2 elements. So out of this, the magnesium and calcium elements are more abundant. The magnesium and calcium elements are more abundant and beryllium is lesser abundant. The beryllium is found in lesser abundant and the radium is radioactive isotope. It is. The radium is radioactive element and it is found rare. So this is the group 2 elements: beryllium, magnesium, calcium, strontium, barium and radium. The strontium and barium have lower abundance. The calcium and magnesium are more abundant in nature and radium is the radioactive element. So this is about the group 1 and group 2 elements. So in group 1 elements we have lithium, sodium, potassium, rubidium, cesium, francium, and group 2 elements have beryllium, magnesium, calcium, strontium and barium, radium. So if you see the general electronic configuration of S block elements, we will write the general electronic configuration of S block elements is n raised to 1:2 2. So this is the general electronic configuration of a s block element. So that is n raised to 1:2, because S has maximum accommodation capacity only 2 electrons. So that is why it will has 1 to 2 electron filling nature, and where n is the period number or else a principal quantum number, where n is the period number or a principal quantum number. Principal quantum number. And the alkali metals. The alkali metals means group 1 metals. Group 1 metals are have general electronic configuration ns1, means in this alkali metals the last electron is only 1, means they will contain 1 valence electron. So that is why the general electronic configuration of alkali metals are written as ns1. And the alkaline earth metals. The alkaline earth metals, that is group 2 elements. Those are having general electronic configuration ns2. The alkaline earth metals are having the general electronic configuration ns2 because they will have 2 valence electron in their last orbital or else a s orbital. So that is why the configuration of alkaline earth metals will become ns2. The alkali metals are having ns1 orbital because they will have 1 valence electron in their s orbital, and the alkaline earth metals are having general electronic configuration ns2 because they will have 2 valence electron in their last s orbital. So that is why this is the major difference in between group 1 and group 2. So S1 alkali metals are having only 1 valence electron, and alkaline earth metals are having the 2 valence electrons. So in this way the alkali metals are showing monovalent nature and alkaline earth metals are showing bivalent nature. Okay, so this is about the group 1 and group 2 elements and general electronic configuration of s block elements. So that is n raised to 1:2. Alkali metals are having ns1 as a general electronic configuration, and alkaline earth metals are having ns2 as a general electronic configuration. And the lithium and beryllium, the first elements of the group 1 and group 2 elements, they should show some properties which are different from those of the other members of the respective group. So in these anomalous properties they resemble the second element of the following group. So thus the lithium shows similar properties to that of the magnesium and beryllium, and the lithium shows similarities to magnesium, and beryllium to aluminum. In many of other properties. So thus this type of diagonal similarity is called as diagonal relationship. So the lithium shows similarities to magnesium and beryllium to that of the aluminium in many of the other properties. So this kind of diagonal similarity is called as a diagonal relationship. Means after the lithium of group 1 element, the magnesium is diagonal to it. So these are exhibit some similar properties. So that is why this kind of relationship is said to be the diagonal relationship in the periodic table. This diagonal relationship is mainly due to having same ionic radii or ionic charge as well as the same size. So these are the responsible for the showing diagonal relationship, because these elements are having, or the diagonal relationship is mainly due to null relationship is due to the similarity of ionic size or a charge or radius ratio. Ionic size, charge or a radius ratio of the elements. The monovalent sodium and potassium ions and divalent magnesium and calcium ions are found larger in biological fluids, and these ions perform important biological functions such as maintenance of ion balance and nerve impulse conduction. The monovalent sodium and potassium means belongs to alkali metals. So those elements are found in more in the biological fluids. So and similarly the calcium and magnesium, those are bivalent in nature, means calcium plus 2 and magnesium plus 2. Those are also present in the biological fluids, and they will makes the importance in the nerve conduction system as well as the biological cellulose system. So sodium and potassium are present in biological fluids. The sodium and potassium are called as monovalent because they have only one electrons in their last orbital. The monovalent sodium and potassium and divalent calcium and magnesium and divalent calcium and magnesium ions found larger proportions, means more amount of calcium and magnesium and sodium and potassium, larger proportions in the biological fluids. So these ions performs important biological functions that is maintenance of ion balance, maintenance of ion valence and nerve impulse conduction. Nerve impulse conduction. So that is why these four elements are important in the biological system also. So sodium and potassium, calcium and magnesium, these will perform important biological function, so such as maintenance of ion balance, so that is sodium and potassium pump, and nerve impulse conductions. So these four ions have important biological functions. So this is about the group 1 and group 2 elements. So the group 1 elements are called as alkali metals. All of these elements are metallic in nature and are called alkali because hydroxides are water soluble. Strong bases are alkalis, since those are said to be alkali metals. And group 2 elements are called as alkaline earth metals, and those hydroxides and oxides are alkaline in nature and found in the earth crust. So alkali metals and alkaline earth metals. So this is the introduction about alkali and alkaline earth metals. So alkali metals include lithium, sodium, potassium, rubidium, cesium and francium. The group 2 elements include group 2. The S block elements are only 2. One is group 1 and group 2. The group 1 elements are lithium, sodium, potassium, rubidium, cesium and francium. So next, the group 2 elements are having the beryllium, magnesium, calcium, strontium, barium and radium. So the lithium is symbolized as Li, sodium, Na, potassium, K, rubidium, Rb, cesium, Cs, francium, or francium is F4. Next, beryllium is Be, magnesium is Mg, calcium is Ca, strontium is St, barium is Ba, radium is Ra. And if you see the atomic number of group 1 elements, lithium has atomic number 3, sodium 11. So the group 1 elements are lithium, symbolized as Li, and it has atomic number 3, and sodium has symbolized as Na and it has atomic number 11. Potassium is K, atomic number 19. Rubidium Rb, it has 37. Cesium is Cs and has atomic number 55, and francium is F4 and has atomic number 87. So group 2 elements include beryllium Be, atomic number 4, magnesium Mg 12, calcium Ca 20, strontium St 38, the barium Ba 56 and radium Ra 88. So in simple manner you can remember the group 2 elements atomic number. So if we add 8 to 4 you will get 12 here. So 8. Then again if you add 8 to 12 you will get the atomic number of calcium. So next if you add 18 to 20 you will get the strontium atomic number. Again if you add 18 to strontium atomic number you will get the atomic number of barium. Again you have to add 32 to that of the barium, you will get the atomic number of radium. So you have to remember 8, 8, 18, 18, 32. So you have to add 8 to 4, you will get magnesium. 8 to 12, you will get calcium atomic number. 18 to 20, you will get strontium atomic number. 18 to 38, you will get barium. And 30 to 56, you will get the radium atomic number. So if you lesser 1, then you will get the atomic number of a group 1 element. So barium has 4 minus 1 should be 3, that is lithium. 12 minus 1, 11 sodium. 20 minus 1, 19 potassium. 38 minus 1, 37 rubidium. So 56 minus 1, 55 cesium. 88 minus 1, francium. So in this way, you have to remember at least beryllium atomic number 4. To that you have to add 8, you will get the remaining atomic numbers. 8, 8, 18, 18, 32. 8, 8, 18, 18, 32. So in this way you can simply remember the atomic numbers of group 2 as well as the group 1 elements. So the group 1 elements are called as alkali metals. These are metallic in nature and water soluble and strong bases, since these are said to be alkali metals. And group 2 elements are alkaline earth metals. Alkaline means basic. Oxides and hydroxides of these metals are alkaline in nature and found in the earth crust. Since we can call them as alkaline earth metals. So next is we will discuss about the group 1 alkali metals as well as the group 2 alkaline earth metals. So first we will discuss about group 1 alkali metals. So these group 1 alkali metals include lithium, sodium, potassium, rubidium, cesium and francium. So these are the 6 elements belongs to group 1 element. So in that we see the electronic configuration of group 1 elements. Electronic configuration. NS1 as a electronic configuration, means the last electron enters into the s orbital and it has only single valence electron. So after removing this single electron from the s orbital, those will become monovalent, means single valent. After removing the one electron from their s orbital, these orbitals means these elements will become monovalent. Those are symbolized as M+. Since it is easy to remove these loosely held valence electron, so that is why these alkali metals are behaving as most electropositive element. The electropositivity is more in the alkali earth metals because it is easy to remove loosely held s electron in their outermost shell of the element. So that's why these alkali metals are get electropositive character. So this will become monovalent after removing the single electron from their outermost element. And if you see the electronic configuration of each element, lithium has atomic number 3, so we can write it as lithium 2s1. So lithium has atomic number, we can write it as 1s2, 2s1, or simply 1s2 is the helium configuration, since we have to write it as helium 2s1. So next sodium is 11, so we can write 1s2, 2s2, 2p6, 3s1, or So 10 is the neon configuration. So simply neon PS1. So next is potassium, it has 19. So argon is 18. So argon 4s1. So next rubidium is 37. The krypton has 36 atomic number since krypton 5s1. So cesium is 55 and xenon has 54 since xenon 6s1. And francium has 87 atomic number and radon is 86 since radon 7s1. So this is the electronic configuration of group 1 metals. Lithium 3, helium 2s1, sodium or neon 3s1, potassium, argon 4s1, rubidium, krypton 5s1, cesium, xenon 6s1, francium, radon 7s1. So in this way we can write the electronic configuration of group 1 elements. So if you observe, the last electron is entered into the s orbital. 2s1, 3s1, 4s1, 5s1, 6s1 and 7s1. So this is the outermost electronic configuration. So if they ask about the outermost electronic configuration of lithium, you have to write only 2s1. So if about sodium, you have to write 3s1, potassium 4s1, rubidium 5s1, cesium 6s1, francium 7s1. So in this way we can write the electronic configuration of alkali metals, and these are having only one valence electron since these are formed monovalent ions, that is M plus ions, and these are showing more electropositive character because the loosely held s electron in the outermost valence shell of these elements makes them the most electropositive metals. So next is the atomic and ionic radius of alkali metals. Atomic and ionic radius. So from lithium to francium, the size of the atom increases. So that is why the atomic radii is also increase in size of the element. The alkali metals have the largest size. The alkali metals have largest size. So that's why with the increasing atomic number, the size of the atom is also increases. Size of the atom is also increases. And ionic radii, the monovalent ions are smaller than that of the parent ion, and the ionic radii is increases from lithium to francium, that is from down the group it should be increases. The ionic radii increases down the group. That is from lithium to francium it should be increases. These are how largest size, and with increase in atomic number the size of the element is also increases because of that reason, the ionic radii is also increases from down to the group, means lithium to francium. So next is hydration enthalpy. So hydration enthalpy is nothing but the amount of energy released during the hydration of one mole of an element. The amount of energy released during the hydration of one mole of energy released during hydration of one mole of element is said to be hydration enthalpy. In this alkali metals, the hydration enthalpy decreases from lithium to francium, means down the group it should be decreases because the size of the atom will increases from lithium to francium. So that is why as the size increases, the hydration enthalpy should be decreases, since the lithium will shows more hydration enthalpy compared to sodium, potassium, rubidium, cesium and francium. So if you write the order, the lithium will shows more hydration enthalpy than sodium, sodium will shows more hydration enthalpy than potassium, then rubidium, and cesium. So that's why the lithium has maximum degree of hydration enthalpy. Means the lithiums are more hydrated compared to others. Lithium hydroxide, it should be more hydrated compared to other. So the amount of energy released during the hydration of one mole of an element is said to be hydration enthalpy. From down the group it should be decreases because with increasing ionic size of the elements. So that's why lithium has maximum degree of hydration enthalpy. So the last property of lithium element is ionization enthalpy. So ionization enthalpy is nothing but ionization energy. Ionization enthalpy. So the ionization enthalpy is nothing but the amount of energy is required to remove the loosely bound valence electron. The amount of energy which is required to remove the loosely bound valence electron is said to be ionization enthalpy or also ionization energy. So here if you see the valence electron, in case of alkali metals, they will enter into the s orbital. So that is why it is loosely bounded. So since it is very easy to remove those electrons, so that is why the alkali metals are having considerably low ionization enthalpy and it should be decreases down the group. So this is because the increase in nuclear charge as the increase in atomic number will take place. So that is why the alkali metals will have low ionization enthalpy. From down the group it should be decreases because with increase in atomic size The nuclear charge is also increases. Also increases. So that is why it is very easy to remove the outermost electron with the minimum amount of energy, since the alkali metals are having low ionization enthalpy. So these are the properties of alkali metals. One is atomic current, ionic radii, electronic configuration, hydration enthalpy and ionization enthalpy. So in next video we will discuss about the further. Thank you.